So with that as an introduction, let me share a little bit about why we are even thinking about climate resilience for the power system. And if you're on the line, I probably don't need to do this, but I think it's helpful to all level set in the same space, right? So these numbers come from some of our research, but I think it's an important message around what we expect to see in terms of electrification. So in order to meet decarbonization commitments, we know that electrification is a part of that equation. And what that means is that by 2050, we have the possibility of seeing anywhere from 43 to 59% of that final energy consumption to be from electricity. Now, even if we do that and we meet those net zero targets, we know that the climate will change. So we have two things that we have to keep in mind. One, a climate that is changing and physical risk to the assets of the power system. And two, a society that is more dependent on electricity because of that electrification, which really underscores the need for resilience. So we know we need to build resilience into the power system of the future with that in mind. We also know that the assets of today are vulnerable, and that understanding what the environment of the future will look like can help us to really plan and build those assets better as we move forward. So this is a project that we did at EPRI that really looked at the rating of transmission lines, which have always thought about and incorporated weather data into that work, right? So historically, you use historical observational data, reanalysis to inform the ratings of your transmission lines. But what we did was we looked at projection data looking out to 2050 and incorporated that and recalculated the transmission line ratings. And what we saw was anywhere from a 1 to 10% decrease in that rating. That is very important for those that are on the line that understand transmission, right? That can really make a difference in terms of the way you think and operate your system. And of course, the consequences of overloading your transmission lines and potentially having sagging, having that come into contact with something is great. So this underscores the need for thinking about the future climate in the planning of our power system with just this one example. We also know that proactive investment in resilience can actually be cost conscious when we are moving forward in the investments in our power system, right? So we did a literature review, and admittedly, there's not a lot of literature out there, but everything was consistent in what it found, which is proactive investment in resilience will cost less than what it costs to respond and restore after an extreme weather event. So I'm not going to go through all of these numbers, but I think it's important to recognize that they are also all conservative. And the reason for that is because they were either looking at one type of event, one aspect of the system. And so we recognize that with these conservative numbers, they continue to tell the story of the importance of proactive investment. So we know we need to build a resilient power system. We know this is a problem that is important across the power system from generation all the way down to the customer. But there's a lack of consistency and confusion around how do we manage the uncertainty that is rife throughout this entire conversation, particularly when we think about what is a future climate going to look like. And so that raises this bigger question about how do we all, and that's why we're here, how do we all evaluate the risk to the power system when we think about extreme weather and long-term climatic changes? And that is why we launched Climate READi. So at EPRI, this is our 3-year initiative to build a consistent and comprehensive framework for assessing the risk across the power system, right? This is intended to be the methodological approach that any company can use to inform the process by which they are assessing these risks. And we have 3 work streams that are currently underway. We kicked off in April of 2022, but we have 3 work streams that are currently underway to advance this work. Work stream 1 focuses on the climate data. So understanding the quality, availability, the suitability of that data for informing these types of assessments. And one thing that you'll see published out this year is climate data guidance. So an actual guidance document to help companies and other industry stakeholders understand how to select climate data. as well as a climate data inventory. So that'll be a great resource to go into and figure out, okay, I need extreme temperatures. That's what I'm thinking about. Where are the different sources I can go to? I'm looking for precipitation and flooding. What are the different sources? And what are the technical characteristics that I can better understand about those sources to inform the decision making of where that data is going to come from? So that's what workstream 1 is focused on. Workstream 2 is focused on asset exposure and vulnerability. So building a framework to enable the assessment of how do I take that climate data and how do I look at an asset level around what might be exposed and what that vulnerability might be. And again, one of the major outcomes of this work are our climate asset matrices, which you see captured on this slide. So another resource that companies and stakeholders can go to say, okay, I have this asset. Here's the weather variable I'm thinking about and considering for our assessment. Here are the impacts that I might see. And here are the thresholds, the actual measures that I need to keep in mind as I'm thinking about my fragility curves and my failure modes. So this will be another valuable resource that will be available to help inform these risk assessments. And then last but not least, workstream 3 is focused on system planning and the prioritization of investments. So we have a major case study underway right now using synthetic data that is available through Texas A&M. And this is our first test of the framework overall, where we pull all of these different aspects of system planning together, do bulk system modeling with distribution modeling, couple that with load forecasting and consideration of weather, and really do that system level regional approach to what do we need to be thinking about when it comes to evaluating the risk. The last thing I'll say before I invite my speakers to join me in this conversation is that we are very thoughtful about this being a collaborative effort and bringing a wide range of voices to the table to inform this work. So I'm really pleased to say we have 42 power companies from the US, Canada, France, and the UK that are helping to contribute and inform the development of the framework. And we have now 97 stakeholder organizations, from regulators, codes and standards bodies, academia, consultants, a wide variety of experience and expertise from around the world that have joined into this effort to help us to build this framework. These are big global questions. We need a lot of perspective in order to ensure the framework is well informed. We are greatly appreciative for all that our affinity group participants, member companies, and of course, our amazing EPRI team are doing to build out this framework.